Hello everyone, to all my friends and my lecturer, which is Dr. Amal. Today, I'm gonna represent my group, which is Group 5 from Session 5, to present our group assignment, which is linear programming. So, here is my teammate. The very first one is me, Hongzhe, and we got Chan Hong, Gordon, Sharul Nizam, Irfan, and Nor Emilia. So before we get into the solution, let's look at the question. So I will read it for you. So let's start. The seasonal yield of olive in a Pyrus vineyard is greatly influenced by a process of branch pruning. If olive trees are pruned every 2 weeks, output is increased. The pruning process, however, requires considerably more labor than permitting the olives to grow on their own, and results in a smaller sized olive. It also too permits olive trees to be spaced closer together. The yield of 1 barrel of olives by pruning requires 5 hours of labor and 1 acre of land. The production of a barrel of olives by a normal process requires only 2 labor hours but takes 2 acres of land. An olive grower has 250 hours of labor available and a total of 150 acres of growing. Because of the olive size difference, a barrel of olive produced on pruned trees sells for $20, whereas a barrel of regular olives have a market price of $30. The grower has determined that because of uncertain demand, no more than 40 barrels of pruned olives should be produced. So the question is, the first question is formulate a linear programming. So let's see. So we in linear programming we have to see our objective function. So the objective function is this one. We have to maximize our this, so we sub into, okay, we got these 3 constraints. So the first constraint is 5x plus 2y smaller or equal than 250. Okay, before that, x is equal to our labor and y is equal to, x is represent our labor and y is represent our acre of land. So right now we create 3 constraints. The first constraint is 5x plus 2y smaller or equal to 250. So the first constraint is talking about the pruned olive. The pruned olive, they have 5 labor and with 2 acres of land. So yeah. And the second one is talking about regular, which is not pruned one. So the formula is x plus 2y smaller or equal to 150. So the third constraint is x, no labor and no, the x is smaller or equal to 40. So this is our 3 constraint, and all of this we can know that we assume that x and y is equal or greater than 0. So when we want to calculate the coordinate of the graph, we must have this objective function. So today the objective function is 20x plus 30y equal to 600. So let me just explain about how we get this coordinate. So the constraint 1, if we take, just now I mentioned that x and y, if we assume that is 0, so the first one we assume that x is 0, so 2y, we move the 2 to the another side, so 250 divide divided by 2, so equals to 125. Same go to the next one is we assume y is 0, so 5 move to the other side, so 250 divided by 5 equal to 50. Okay, this formula can sum both all of the equation we used for today. So constraint 2, same method. So if the x is 0, so 2 will move to another side, so 150 divided by 2 equals to 75. When y equals to 0, then x automatically will become 150, and x is equal to 40 for the constraint 3. There's no any problem. So the next one, the objective, we also use the same formula. So when x equal to 0, y, the 30 y will move to 600 there. So 600 divided 30 will equal to 20. And the x, when y equals to 0, 20 will move to another side. So 600 divided 20 will become 30. So this is our objective function. So with all of this, we can draw our graph out and see. So this is our graph. Okay, pen and the line. Okay, the very first one, okay, like that cannot see, okay, like this. Okay, the first one, C1, constraint 1, we got y, we got 125, and x we got 50. So the color, choose the color, let's use purple. Okay, so 250, 125 to 50. This is our C1 here. Okay, so the second one is the blue color one, so we change to blue. Okay, the second one is y equal to 75 here, and x equal to 150, so about here. Okay, so the third one is x equal to 40, and y is nothing, so we just draw a straight line here. Okay, so as you can see, this is our graph, and the objective function is is 20 and x, y is 20 and x is 30. So here we use the dotted, okay, don't have dotted, it's okay. Wait, let's see why. So sorry, I draw again. Okay, so the function is, we use red color. So y is 30 and x is 20. Here, so we can know that our total harvest will be on this side. So I paint it with gray color. So here is our total harvest, I would say. And when the constraint 1 and constraint 2, they across each other, this is our optimal solution. Pen. Here, this is our optimal solution, this point. Okay, if you still don't know why is it located at here, we also can use back the formula base to count. Okay, so let's see. Okay, how we gonna count out our optimal solution is, we use the first constraint, which is which is 5x plus 2y equal to 250. So we just, right now we want to find out the value of x. So we move y to another side. So positive 2y will become negative 2y. And we move 5 to other side as well. So 250 divided by 5 will get 50. And 2 divided by 5 will remain 2 over 5. Or you want to write 0.4 also can. So right now we remain the same. Okay, so this is value of x. Right now we use constraint to sub the value of x in. So constraint 2 is x plus 2y. So x will equal to 50 minus 2 over 5y plus 2y equals to 150. So same, we just open the bracket and calculate all this. So 50 we move to other side, positive when we move to other side will become negative. So 150 minus 50 will equal to 100. And 2 over 5 y plus 2y. Okay, y become 8 over 5 because this 2y will how we say, we break it become 10 over 5 y. So 10 minus 2 will equal to 8. So 8 over 5y equals to 100. So we move this, go to another side. 100 times 5 divided by 8. So we will get 62.5. So the value of y is 62.5. So the x, when we got y already, we sub inside this equation again. Sub the y inside. So 50 minus 2 over 5 just now is y. So right now we got the value of y. So 62.5. So after we calculate x, we will get 25. So when you see the x is 25 and y is 62.5, it's same as our graph, the cross one here. If you look, if on the graph paper you can see here is about to reach 62.5. I change the color first. And here is about 25 here. Right? So after we got the optimal solution, then we can count our optimal value. So just now the function is, the objective function is 20x plus 30y. So right now we just sub the value inside. So 20 plus x is 25. So 20 times 25 plus 30 times 62.5. So the answer we got is 2375. So that is our solution. So thank you guys. This is our presentation. So I hope you all understand it, and thank you so much.